Welcome to the module on durability of concrete. In the previous module, we talked about the permeability test. Now, in this particular module, we will be talking about the RCPT test. RCPT stands for Rapid Chloride Penetration Test, which is again a measure of durability of concrete. In this particular module, we will talk about the method of test and the significance of RCPT test in concrete. Durability, by definition, if you see, durability of concrete is defined as its ability to resist weathering actions, chemical attack, abrasion, or any process of deterioration while maintaining its desired engineering properties for the expected service life of the structure. When we say the desired engineering properties, like its load carrying capacities, its aesthetic views, and also the capacity to withstand in its place by taking the load. So basically, the durability is directly related to, or we can explain, we can simplify saying that it is the life of the structure which we are talking about. Like, for example, if a particular structure is designed for, say, 50 years, then we intend to say that the durability of that particular structure should be such that it should be able to perform and withstand its intended use for a period of 50 years. Now, the factors affecting the durability are permeability and diffusion, the properties. Second is the exposure conditions, like normal exposure, moderate exposure, severe exposure, and very severe exposure. Depending upon the environmental conditions, the exposure conditions are being defined in the codal provisions. IS 456 also gives a clear indication of the different types of exposure conditions, and based on the different exposure conditions, the minimum cement content and the maximum water cement ratio is also being established in the standards. Then it comes the water cement ratio. When the water cement ratio is low, the durability is high. When the water cement ratio is high, the durability is less, because when the water cement ratio is high, the porosity of the concrete is high. Thereby, it will have a major concern as far as the movement of the chlorides and detrimental acids are concerned through the concrete. So it is important that you should maintain a water cement ratio which is stated in the standards, the maximum water cement ratio, and it should be as low as possible to get a concrete which can be easily mixed, placed, compacted, and finished for a particular member. Then the other relevant or the significant properties are the effectiveness or the efficiency of the curing. The curing has to start on time. As early as possible, the concrete is attained its shape in the formwork. The curing has to be effective, because if the curing is not effective, then the cracks will develop, and those cracks will be the guides for a movement of water and chemicals and acids through the concrete. And as the cracks develop larger and larger, the reach of the chemicals and the chlorides to the reinforcements which is being embedded in the concrete will be high, thereby creating a corrosion of reinforcement and affecting the durability of the concrete. Then comes the compaction. One has to make sure that the compaction of the concrete is achieved 100%. In our previous modules also we talked about compaction as a separate subject, thereby showing how the presence of voids will have an impact on the strength of the concrete. So if the compaction is not achieved 100%, then significant impact on the strength of the concrete can be seen. And the last but not the least is the supplementary cementitious materials. The use of supplementary cementitious materials always enhances the properties of durability of concrete. The presence of supplementary cementitious materials increases the density of the concrete, thereby minimizing the voids and minimizing the movement of acids, alkalis, and chlorides through the concrete. So it is a direct way of improving the durability of the mixes. So if the concrete is being prepared using a supplementary cementitious material, then obviously the permeability and the diffusivity of the concrete will be improved, and the RCPT values can be improved further. Lesser the RCPT values, higher will be the durability or the life of the structure. That's how it is being defined in the standards. Now, the permeability and diffusivity are the two main factors affecting the durability of the concrete. In the previous module, we talked about the test, permeability test, water permeability test in concrete. Permeability is defined as the property that governs the rate of flow of a fluid into a porous solid. Now, diffusivity refers to the ease with which the dissolved ions move through the concrete. So this is basically the definition of permeability and diffusivity of the concrete is concerned, which is directly affecting the durability of the concrete. Now, how to control the permeability and diffusivity of the concrete? Again, the four factors. One is water cement ratio, second is effective curing, third is packing of aggregates, and the fourth is use of supplementary cementitious materials. When it comes to water cement ratio needs to be always lower as much as possible in order to increase the durability of the concrete by reducing the permeability properties. Effective curing means improved curing will reduce the permeability of the concrete, because improved curing will reduce the cracks developed on the surface of the concrete, which will not further allow the movement of the liquids inside the concrete, thereby reducing the permeability of the concrete. And when it comes to packing of aggregates, increased packing or dense packing of aggregates will have improved permeability of concrete, thereby having a significant impact on the durability of the concrete. Then finally, the use of supplementary cementitious materials reduces the permeability and diffusivity of the concrete, which will have an improvement in the durability properties of the concrete. So coming to the second test, which is commonly known as the rapid chloride permeability test. It is a test for the reinforced concrete elements, or the grade of the concrete which is being used in the reinforced concrete elements. One of the major forms of environmental attack is chloride ingress, which leads to corrosion of the reinforcement steel and a subsequent reduction in the strength, serviceability, and aesthetics of the structure. So the ability of the chloride ions to penetrate the concrete must be measured and known for the designers as well as the quality control purposes and the quality control engineers, in order to make sure that the element which is being built by using a particular grade of concrete is not allowing much of the chlorides to move through it, thereby minimizing the corrosion of the reinforcement, and hence the minimizing the, or hence maximizing the life of the structure. Rapid chloride penetration test, or rapid chloride permeability test. This test method covers the determination of the electrical conductance of concrete to provide a rapid indication of its resistance to the penetration of the chloride ions. This test method consists of monitoring the amount of electrical current passed through 51 millimeter thick slices of 102 millimeters nominal diameter cores or cylinders during a period of 6 hours. That means the test duration is basically 6 hours. Sample preparation will take some more time, and so a maximum of 8 to 10, 7 to 8 hours you will be able to complete this rapid chloride penetration test or the permeability test of a particular grade of concrete. So these are the arrangement. This is the arrangement of the samples to be kept for testing. This is the outer cell with a sealing in between, and then the center one is the case where the samples are being placed. Now this is the typical arrangement. Once the samples are being placed, it is being tightened from both the sides, and then you have electrical condensers passes from one portion to the other portion. So this test method covers the determination. A potential difference of 60 volt DC is maintained across the ends of the specimen, one of which is immersed in sodium chloride solutions and the other is sodium hydroxide solution. A total charge passed in coulombs has been found to be related to the resistance of the specimen to chloride ion penetration. So this is a typical sketch, the RCPT test arrangement, where you can see that on one side you have NaOH solution and on the other side you have sodium chloride solution, which is being thermocoupled. The samples are being sealed and covered by the silicone rubbers. Okay, and then a positive charge is applied from the sodium hydroxide solution side, and the negative charge is connected to the sodium chloride side, and then the movement of the chloride ions from one portion to the other is being measured. The specimen diameters other than 3.75 inches or 95 millimeters. The test results values for a total charge passed must be adjusted using a correction factor. For specimens with a diameter less than 95 millimeters dia or 3.75 inches, particular care must be taken in coating and mounting the specimen to ensure that the conductive solutions are able to contact the entire end areas during the test. During the test, the air temperature should be around the specimen should be maintained in the range of 20 to 25 degrees centigrade or 68 to 77 degrees Fahrenheit. Transfer the specimens to a sealed can or other container which will maintain the specimen in 95% or higher relative humidity. So these are the conditions which one has to maintain during the RCPT test, or we can say the precautions required for RCPT test. The limitations of a RCPT test are the test method applies to a 102 millimeter nominal diameter specimens only. This includes specimens with actual diameter ranging from 3.75 inches or 95 millimeters to 4 inches, that is 102 millimeters. Other specimens diameters may be tested with appropriate changes in the applied voltage cell design. That means it needs to be again redesigned as far as the application or the differential voltage requirement is concerned. Since the test results are the function of the electrical resistance to the specimens, the presence of reinforcing steel or other embedded electrically conductive materials may have a significant effect. So it is always important to make sure that there is no such element present in the sample. The test is not valid for specimens containing the reinforcement steel positioned longitudinally, that is providing a continuous electrical path between the two ends of the specimen. That means your electrical reinforcement should not be a carrier of the chloride ions. So this is a typical arrangement with 0.3 molar, 0.3 m sodium hydroxide and 3% of sodium chloride on both sides with a reservoir. Then the concrete specimen of 102 millimeters diameters and 50 millimeter thickness is placed between the two. with a 60 volt of DC is applied for a duration of 6 hours, which is being measured on a LCD display to determine the current passing through the concrete. So RCPT test procedure, if you see, it is being conducted as per ASTM C1202. Corrosion is mainly caused by the ingress of chloride ions into the concrete, annulling the original passivities present. Rapid Chloride Permeability Test or RCPT has been developed as a quick test able to measure the rate of transport of chloride ions into the concrete. This test was conducted as per ASTM C1202-94. Concrete discs of size 100 millimeters diameter and 50 millimeter thick, with or without GF, were cast and allowed to cure. After curing, the concrete specimens were subjected to RCPT by impressing 60 volt. Two halves of the specimens are sealed with PVC containers of diameter 90 millimeters. The other side of the container is filled with 3% of sodium chloride solutions. That side of the cell will be connected to the cathode terminal of the power supply, and the other side, which is sodium hydroxide solution, was poured and connected to the anode terminal as shown in the figure. So this is how the typical arrangement of the RCPT test is being shown. You have a data logger, you have a printer, then you have two cells which is being connected to cathode and anode with a stainless steel cathode portion on the one side, having 0.3 mole sodium hydroxide reservoir and 3% sodium chloride reservoir having a stainless steel anode connector, and the sample is having a diameter of 100 millimeters and 50 millimeter long, with a top surface facing the sodium chloride solutions. The specimens were fit in the chamber with the required brass as well as the rubber o-ring. The record time is set as 30 minutes and also the log time as 6 hours and 30 minutes, and the current of 60 volt is passed continuously. The data logger records the readings of the corresponding cells at every record time with its initial reading set. At the end of the log time, the system halts after taking the final reading. So this is how the recording of the data is being done during the RCPT test as per ASTM C1202-94. I0, I30, I60, I90, I120, like that up to I360. I0 means the initial current reading in milliamperes. I30 stands for the current reading at 30 minutes in milliamperes. I60 is current reading at 60 minutes in milliamperes, and I360 is the current reading at 360 minutes in milliamperes. So during this period, the current passed in milliamperes is being measured and recorded. So once that is recorded, the calculation is being done using the formulas. Like from the results using the current and time, chloride permeability is calculated in terms of the total charge passed in coulombs at the end of the 6 hours by using the formula given in the equations. The average current flowing through one cell is calculated by I is equal to 900 into 2 times I cumulative in coulombs, where I cumulative is nothing but sum of the current passed at each interval starting from I0 plus I30 plus I60 plus I90 up to I360. The evaluations of the test results, or the significance of the test results, are if the total charge passed in terms of coulombs is more than 4000, that means the chloride ion penetrability is very high. When it comes to 2000 to 4000, that means the RCPT value is moderate, or the chloride ion penetrability is moderate. When it comes to 1000 to 2000, that means it is low. What is required is low and very low. Normally in metro projects we have RCPT values sometimes defined or given in the contract that it should be less than 1000. That means the life of the structure will be high when the chloride ion penetrability through the concrete is low or very low or negligible. So always for the important structures, the RCPT value is maximum to the range of 2000, and anything above 2000 is not advisable as far as the RCPT value is for a particular grade of concrete is concerned. And when the durability of the structure or the element is high to the tune of say 50 years or 100 years or 120 years. So what is the need of RCPT test? It improves the durability of the concrete. In fact, it indicates the durability of the concrete, and in turn, to achieve the RCPT value, we need to increase the density of the concrete. We need to minimize the permeability of the movement of the chloride ions, thereby improving the durability of the concrete. So RCPT value is an indicator which will decide what is the life of the structure you are planning for. So when you are planning a life of structure, say around 50 years, but you say that I need a RCPT value of say 4000, that means definitely your life of the structure won't be 50 years, rather than it will be much less. So depending upon the life of the structure, the RCPT values are being set, and RCPT value is in turn is an indicator of the life of the structure or the durability of the concrete. It also measures the movement of the chloride ions in the concrete, thereby indicating that how fast the concrete or the structure will be deteriorated because of the corrosion of the steel reinforcement which is being exposed to the chlorides present in the air. It also determines the cover to the reinforcement depending upon the rate of chloride ion movements in the concrete, and of course the density of the concrete as it is being defined in the permeability test in my previous modules. So the significance is a rapid indication of concrete resistance to chloride ion penetrations, suitable for evaluation of materials and material proportions for design purpose and research and development purpose. It signifies the durability of the concrete being used in the structure, and the life expectancy of the important structures can be estimated based on the RCPT values being achieved for that particular grade of concrete. So to summarize, in this module we talked about the durability definition, the factors affecting the durability, the definition of the RCPT test, the significance and use of the RCPT test, the method of conducting the RCPT test, the precautions required to be taken to conduct the RCPT test, and the test procedures of the RCPT test. With this, we come to the conclusion of this particular module. Do get in touch with us in YouTube through Highway Guru, and you can also visit my site, that is the qualityguru.in, for any queries related to the civil engineering. Thank you very much for watching this module.